Okay, now I will present to you about sampling methods. My study case is Daifuku Mochi, but I guess we are already know what is it, and I will skip this to save our time. So for the first method is simple random sampling. This is the most widely used type of sampling. A sample selected where each item or person in population has same chance of being included. This random sample can be used where population is homogeneous. For example, we want to take 50 employees from a company that has 300 new employees. In this case, all those employees have the same chance to be included because they are all homogeneous. Now, for the example, every Monday, our stores gives 25% discount to our students buyers, but only 10 selected students can get this discount. There are 50 buyers in the queue area. If we want to take sample to know who will get the discount, we can use the sample random sampling. In this case, the population is 50 buyers because all students has the same chance to be included. The second method is systematic random sampling. This is the method where we take a sample in systematic way with the interval or range of the samples that already be sorted. We must use this method where the population is large and homogeneous. For the example, suppose that there are 70 buyers from our store today, and we plan to take 5 samples randomly. In this situation, we can use systematic random sampling because our population is large. And we got the formula where Q is interval range equal to the population size divided with the sample size. We got 70 divided with 5, and our interval distance value is 14. Next is the stratified random sampling. This is the sampling method where the population is divided into subgroups called strata, and a sample is randomly selected from each stratum. We will use this where we can divide those population of groups based on their characteristic, gender, or etc. After divided, we can use some simple random sampling within each group of populations. For the example, we will take a sample to our buyers based on their most purchases in each variant. We have chocolate 20, matcha 40, original 30. We can take sample in proportional way. That is when we take a half of the buyers, that will be chocolate 10, matcha 20, and original 15. Because this is the proportional way. And next is the cluster sampling. A population is divided into clusters using naturally occurring geographic or other boundaries. Then, clusters are randomly selected and a sample is collected by randomly selecting from each cluster. We can see in the image on the screen, there are 6 cluster population. This is based on 6 locations, but we will not take all these 6 to be our sample, but instead we are only take 2 sample. And next, we're gonna discuss about the sampling error. This is the difference between a sample statistic and its corresponding population partner. The error happened because the sample may not be a perfect representation of the population. The size of error depends on which sample is selected. It can be positive or negative value. We can get the value by subtract the population mean with the sample mean. This for the example, we have the data sales for 2 weeks. These 12 values are the population. In order to find the sampling errors, we need to firstly find the mean of the population and sample. Here we can see in the picture the population of data cells in 2 weeks. And if a If a simple random sample of n is 5, includes the following 10, 12, 15, 17, 18, what is the sample mean and sampling error? Nah, we can get firstly the x equals to sigma x divided with n, and we can find the 72 by sum all the sample and divide it with the total population, that is 5, and we can get 14.4, and after that we can subtract the x with the mu, that is the mean from the previous slide, and we can get 14.4 subtract with 19.16, and we can get minus 4.76. That is the value of sampling error value using this formula, that is x bar minus mu. And the last part is sampling distribution of the sample mean. A probability distribution of all possible sample means of a given sample size. This will help eliminate variability when we are gathering statistical data. It also helps make the data easier to manage and builds a foundation for statistical inferencing, which leads to making inferences for the whole population. Example of sampling mean, there we have the total of employer from all our branch store with their total working hour. We got from 4 hours, there is 20 employer, and 8 hours, 50 employer, 10, there is 15 employer, 2 hours, there is 10 employer, and the last is 6 hours, there is 30 of employer working in that hours. From this example, what is the population mean and what is the sampling distribution of the sample mean for sample of size 3? We can get the mean of our population is 25, that we get from sum all of the total employee here, the 20 and all, and divided with the population size. Because the population size is 5, we must divide the 125 with 5, and we can get the mean, that is 25. And for got the sampling distribution of the sample mean of size 3, we can use n combination with the n, and n factorial divided with n factorial, and then times n minus n factorial. There we can see it is kind of complicated, but we only times 5, 4, and then we divide it with 2. Why? Because the above and below is already have the 3 value, and because of that, we don't need to calculate the 3 anymore. There we can find 5 times with 4 is equal to 20, and then for the 2 times 1 is 2. Then we can divide it. 20 divided by 2 is 10. I think that's all for my presentation today. Thank you for your attention, guys.